I'd like to introduce you to Emre Gültekin, CEO of Chooch. And after the webinar is concluded, we'll take questions and answer your questions in the Q&A panel. If you're watching the recorded webinar afterwards, thank you for watching, and take it away, Emre.
Thank you, Jeff. Thank you, everybody, for joining the webinar. Today, we're going to talk a little bit about visual AI as a service. Some of the problems that we face today in AI in particular is execution and deployment, and actually making it useful for enterprises. And with the adoption of any new technology, we have these issues. So we're going to talk about how useful visual AI is for a lot of our companies that we service today, and just brainstorming about future use cases with you as well. So why do we really care about this? It's basically, it's all about productivity. And with any type of new technology coming on board, you see spikes in productivity, and that spike in productivity creates growth. And here we're seeing a very similar situation with AI. Although it's very, very early and there's a lot of hype involved, we're still seeing that growth, and we'll probably be seeing it for the next, let's say, 10 to 20 years going forward. So there's growth involved, and we need to be involved in that growth. And we as practitioners in AI need to be able to execute and provide valuable products to our clients moving forward. And that's why the time is now. Time is now to actually deploy these and make them useful for enterprises. So the problem that we're solving as a company is actually quite mundane. It's tagging of images and videos. So when we talk about visual AI, we're actually talking about cloning human expert vision into a machine. So whether that is you're an expert in pathology, or you're an expert in aircraft engines, or you're an expert in certain sports, agriculture, whatever your capabilities are, we want to be able to clone your capability to tag things, tag images, and tag videos, and put them into a machine. So it's a very basic problem, and this is all done manually today. So we're trying to automate that process. And you can see here, it's who is in this image, what is that person wearing, did the batter hit the ball, how many sheep are in this herd, should we give access to this person, and so on and so forth. So it's a very horizontal in that sense. And when we talk about visual AI, we're really talking about this component of it. But before we give you an example of the visual AI matrix and how complex it is in terms of execution, in terms of creating a turnkey product for clients. Although the input and output is quite simple, what we're talking about here are different platforms in visual AI. So the top line over there is image, object, face, dense classifier, text, and time. These are different areas in visual AI, and they're different because they use slightly different neural nets and frameworks depending on how they're developed and deployed. And it's very important for a visual AI company to be able to combine these into one type of corpus. And on the left-hand side, you see the processes involved in actually delivering that product. And it's quite complex, from all the way from data set collection down to how you create your dashboard. So most of these need to be ticked in order for you to be able to provide a turnkey product for your client. And there are two reasons for this. The first reason is validation. If you look at human vision, we use all of these different aspects to validate each other during the prediction process, and we want to make sure an AI can do that as well. So if you're just doing face and you don't have object, you're going to have a liveness detection problem. If you're just doing object and not dense, then you're going to have accuracy problems in your object detection as well. So these are some of the problems that we see, and this is the visual AI metrics that we had to tick in order to make things work. So what are we really doing? The problem is manifold, as stated in the previous slide of the visual AI matrix. But basically, what we're doing is we're trying to create a corpus that doesn't have to relearn everything every time a new model is developed. And so this corpus of identity, these corpus of models, and we call these models perceptions, is developed based on certain categories and certain expertise and also certain enterprises. So we're able to do this, and we call these perception libraries. Perceptions are classically, they're called models, but they're not just models here. They can be a single model, or they can also be a cluster of models. So that's why we call them perceptions, because they're actually more than just models of neural nets. The machine learning process that we use is mainly transfer learning, and we used the initial ImageNet library many years ago to train the basic corpus of our system, and that gives our system a certain understanding of the world by itself, and then we developed the remaining amount of corpuses and perceptions on top of that. So we're looking at 165,000 plus classes trained to date in over 100 models. And our goal here is to reach about 10 million classes over the next 18 months. And that is major scale in terms of developing this type of visual AI. It's a very basic input and output mechanism. So what we're really doing here is metadata generation. So you place your image in, or you stream your video, and you get a response from the API. So it's a very basic input and output system. It's an API, and what you do get is a JSON response with all the different tags and the coordinates of those tags involved. So if you're using, for example, the pre-trained perceptions, you'll get out of 165,000 classes, you'll get tags based on that. And if you train your own, which is the reason we built the system, is you'll get metadata based on your own training of the AI. So this is how we started. We started with media enrichment for different broadcasters, press agencies, and video commerce companies. And basically, they have photographers on the field, videographers on the field who are taking images at these different events. And you can imagine they're taking thousands and thousands of pictures or videos. And what they're doing is, first of all, they don't have the time, nor do they have always the expertise to tag these manually. So what they're doing is they're running it through our API, and we're sending back these different tags in real time and this becomes part of the IPTC fields in that particular image, or it becomes part of the database for that video file. So this is a very obvious use case, and that's why we're presenting it first, because that's really how Chooch began, and also with e-commerce identifying these types of pieces of of product and trying to assemble them, and based on the attributes, actually pricing it as well. So these are use cases that we're doing right now, and it's being used by several of our clients. Here's another use case which humans do really well, like complex counting, and whether it's counting sheep or counting cells, it's basically the same type of action. So humans do this really well, and the problem with humans is that we do it slowly. The thing here is to scale it and to make machines do it, so that it can become ubiquitous and also can be very, very fast. So this is one thing that we're doing for our clients today, in all the way from agriculture to pathology. Here's another obvious use case that we're working with banks on, and also large enterprises who have contractors overseas, is basically facial authentication. And this is part and parcel of facial recognition. We know about facial recognition a lot because it's on the news a lot, but what we're doing is mainly facial authentication, which means it's facial recognition plus a liveness detection. So is that person real? Is there a mask on that person? Is it a video? And you can see on the left-hand side there, you'll see a mask, and also a person on an iPhone, or it's an iPad, and then the real person on the left-hand side. So you'll be able to, the AI needs to be able to understand the difference between these and to authenticate that person moving forward. So this is a basic, this is a more understandable use case, but it's fundamentally the same platform. So different types of sensors. You've got, you have optical before, and this is called synthetic aperture radar. And this is done by drones, high altitude drones. And what we're doing here is we're identifying assets on the ground at 99+% accuracy. This is really crucial for anyone who has drone imagery, high altitude satellite imagery, and so forth. So we do a lot of change detection and also identifying these types of assets. So it is sensor agnostic. So here this is a special type of imagery. It's SAR imagery. So it's the same with infrared or optical or any other type of FLIR type of imagery as well. Here we have something that's also somewhat obvious, but difficult to detect. And this is called anomaly and change detection. So very, very small changes in certain imagery. On the left-hand side, you could see also it's satellite imagery of some vehicles that appeared from nowhere. And then on the right-hand side, what you're seeing is scratches on a disk in the manufacturing process. So any type of anomaly and change detection is being done by the same platform, by Visual AI. And this is particularly important for any type of a manufacturing process or any type of disaster relief and so forth. Here's a more recent use case, a couple of use cases that we're doing, and it's action logging. So basically logging of actions. And again, humans do this really well. The problem with humans is always scaling. Humans do math really well as well, but we don't do math anymore. We let the machines do it. So this is in that process. So did the batter hit the ball? Who's the batter? And then in an operating room, do people have their gloves on, masks on? How many gauzes were used? How many times did the doors open? Like who's in the room, and so forth. So you have these types of actions that are important to log and to create call to actions for people to understand what's going on, or if there are any type of anomalies in that particular action. And at the end of the day, it really comes down to doing this on the cloud. So the basic principle is the infinite scale on the cloud on GPU servers, but also being able to put basic capabilities on the edge. And so we deployed right now on the edge as well up to 1,100 classes in different areas like industrial IoT, facial authentication, authorization, robotics, and pedestrian detection on different types of devices. So the purpose of edge is to relieve some of the stress on the network, and also to be able to function in like a remote area, like mining, oil fields, or certain remote areas where there is no connection. So it was really important to be able to do that for that particular space. Here we have another use case, and that's big box analytics. So you have robots walking through, or rather rolling through aisles and taking live stream video of these products, and these products need to be reported whether they need to be stocked or not. So the left-hand images and video feed come from the robot, and then we provide the UPC and location, and also the whether that product needs to be restocked or not, or whether it's like messy or whatever. And this is a manual process today. It's done by humans, obviously. So this is another use case that we have deployed. Another important one, and probably more futuristic, and this has been like the golden, something that advertisers and also broadcasters have been going for a while, is interactive TV. It's basically interactive video, being able to touch people and touch objects inside video. The first order of that, obviously, is to be able to recognize things. If you don't recognize them in real time, you can't generate this type of content. So this is another one where we're deploying right now with one of our largest clients. This is also futuristic, and also one we're working with one of the top 3 for augmented vision, and that is to be able to identify people and things in real time in these AR glasses that are coming out. So this is something that we're working on. It's actually the same principal, platform, API, and it does exactly the same thing. So it's the same, you train it the same way, it recognizes it the same way. It's wildfire season, so we started working last year on this with some of our partners in order to detect possible fires before they happen, or as they happen in the first few minutes. So this is something that's very useful. It's impossible to do manually because you have to look at all the forestry in the United States or whichever country you're looking at to detect these types of fires as in the first few minutes of them happening. So you have to look at each acre at all times. So this is also a use case that we're delivering, and it's also very useful for other types of disaster relief. Content delivery, zoos, museums, technical manuals in the field, any type of travel content, basically, same thing. You have an input of an image or a feed of a video, and then you're getting these tags, and that is very, very useful for this type of content delivery and providing these types of actions and this type of user experience to users in those areas. So just a little bit about the dashboard and how to use Chooch right now. It's a very simple to use API and dashboard. Here you have basically the pre-trained perceptions, and you can log in and start viewing what type of perceptions they are, and start uploading your images as well. You can create your own perceptions. So here, this is the image classification perception. You can create your perception and then create your classes on top of it without having to code a single line of code. And uploading images is very, very similar here, right? So this is SAR imagery that we're uploading onto the Chooch dashboard. It's a very simple to use API. It's a one line of code, and you can basically put it into any type of consumer-facing app or enterprise app that you may have. And I want to leave you with this, and this is really crucial because people may ask, okay, why are we really doing this? And it's all about productivity, and it's about productivity in visual AI. So here we have a formula where you have a bunch of visuals, and you need to make a decision on those visuals. So it's a cluster of visuals that need to be identified, analyzed, and then a decision needs to be taken from those visuals. So here you have the amount of people doing that task, and then you have the time it takes to analyze each visual, and then the number of visuals that you have, and finally you have a cluster of a decision at the end of the day, which is represented by the large D. So the human element here is important, and this is one of our clients with aircraft inspection, and it takes about 80 seconds to analyze each visual task. So 80 seconds, you have 101 visuals in this thing, and this is a video. This could also be a series of images, and then you have 4 people doing it. So it approximately takes 9 man-hours to do that today. And so when you look at that, that's quite a lot of time and money. And if you, at the end scenario where everything is perfect and the machine is able to do it, the video inspection of that aircraft, basically everything comes down to 1. So you have, it's 1 second to do the visual task. You have 101 visuals. The machine is just 1 because it's just 1. It's not 4 people. It's just 1 machine, and it takes 101 seconds. But if you multi-thread that, it comes down to 1 second. So everything like converges to 0 almost when a machine does it. And this is the perfect scenario. So this doesn't exist yet, but if you keep training the visual AI so that it becomes a perfect expert in that, then it does come to that level. And the only caveat here is that you need to have eyes everywhere. So you need to have cameras everywhere possible. So this is a productivity formula which we're using to demonstrate some of the benefits of visual AI in these enterprises. So yeah, thank you, and I guess we'll start taking questions. And right now.
Does anyone have any questions? If you do, please ask in the QA box. It's at the bottom of your browser. You'll see a green share button, and left to it is the Q&A tab. But if you don't have any questions, you can also just follow up with us by email, and happy to answer your questions. Someone just wrote thanks, and you're welcome.
Do you have any questions, Jeff?
Well, how did you know, I know the answer to this, but it's really interesting how you and Hakan got started. Perhaps you could tell us,
I guess people really they get hooked on the name Chooch, and I want to start with that because that might be one of the questions that people may have.
Yeah, what does the name Chooch mean?
Who they may be embarrassed to ask about. So, so Chooch it has a dual meaning. It's both. It's a mix of choose and search, and we believe it's the future of search in that sense because things are going to be more visual in the future, and we're going to search visually. And then there's another meaning which it's dummy. It means stupid or idiot in an Italian dialect, and people take comfort in like calling AIs dummy. And this is an AI, so it's still a dummy.
Yeah.
So that's kind of the story behind Chooch.
Yeah, AI knows nothing until you teach it, right? It's completely.
And even if you teach it, it's limited in its capability to make those types of inferences.
You like to say that that we're cloning human expertise. So, I mean, how do we do that? How do we clone human expertise?
Yeah, that's a great question. So there is a training process inside Chooch right now where you upload images and you annotate. And so it's really a mix of annotation, and only experts know what to annotate. And so if you're able to do up to 30 images, it starts recognizing those things like an expert. So it's cloning expert vision, yes, but only to the extent of tagging capability. So don't read too much into that. It is cloning, but it's cloning the capability of that expert to be able to tag those images.
Right. And can Chooch do this for companies or organizations? Can Chooch do this kind of training?
Yeah, well, we do the training currently, as you know.
Yeah.
So it is an open platform, so people can try training themselves. But usually, when it's something that's more complex, we like to get in there and train for the first onboarding process, and then we let the enterprises train if they want to train. If not, we can continue training for them. Yeah.
You know, this the link at the bottom of the thank you page, that's a link where people can go to get our demo, which is either an Android or an iPhone app. And what that app does is it sends video to our server, and the server interprets that video and adds tags to it from the perception library that's open to the public. So that's what that link is doing down there, the Chooch AI/demo. So
yeah, you can actually if you download IC2, you can do training on IC2 as well. So you can do face, object, image training on it as well. But if you're doing something enterprise grade, it's better to use the dashboard.